Oops. Alrighty, welcome back to 105. So we are ahead of some of the other sections. So before I start and we practice using strings, any outstanding questions or concerns with what we have gone over so far? All right, so everyone's great with strings. All right, so let's get into it then. So, little early review for the final. So here is something from the final exam in 2022. So it says complete the following function to alter the string. Don't really have to alter the string in this case, and remove any leading zeros. You are not allowed to change any part of the provided C program. So what was actually given that has a little bit of the solution is this. So there is a main, starts off by declaring a string on the stack. So it is an array equal to a string literal, so it actually gets copied there from C. Turns out we don't actually need to know this for this question because we are not modifying that string in any way. So this just calls print num, and print num should just print that string without any of the leading zeros. So if I were to implement this, I just have to print out the string without any leading zeros. That's it. I don't have to actually modify it. I don't have to do anything like that. So anyone want to tell me what I should do so that this put s, which is basically just print f, just with the string and the new line, how I can get that to ignore the leading zeros if my input was something like this. So 0, 0, 0, 0, 0, 8, 9, whatever. Yeah?
While the current digit is 0, you move the pointer 1 by over?
Yeah, so right now, when we, for this input for print num, it gets a pointer to a string or pointer to a char, which is a C string. So initially, it will be pointing to this value of 0. So if I want to print that entire string with the zeros, I just put s there. It would print everything. If I want to go ahead and skip any leading zeros, well, I can just adjust the pointer such that I keep moving it forward until it is not pointing at a 0. So there's lots of ways to write this. I can use the I could use the array notation. I can use pointer arithmetic and dereference. Doesn't really matter in this case. So one way I could write this is I could just put a while loop. So while dereferencing the current value of s, so right now it would actually give you the value of the character that it's pointing to. So while the value of the character it's pointing to, oh, sorry, it's not called s, it's called stir, is equal to 0. So while it is equal to 0, I can just do simply plus plus stir. So that will keep on moving it one character until the character it's pointing at does not equal 0. So anyone have problems with that? Short and sweet little solution, huh? So if we go ahead, compile it, and run it, it's called short. Oops. So compile and run that, boom, works. Easy. Yep. Yep.
Then when you print it, it prints everything after that first index?
Yeah, so in this case, string, the argument that is given in this program, so it's a pointer copied by value like before. So it is pointing to this 0. And when we do pointer arithmetic like plus plus stir, that's the same as doing stir equals stir plus 1, right? So that's going to do pointer arithmetic and move it forward one character and also modify it. So the first time through the loop, we dereference what it's pointing to, which would be the character 0. So its value is 0. We'll go into that loop. And then we'll change the pointer such that it is pointing to this digit, or this character here. Right? And then that's true. So we point to the next one, the next one, the next one, until eventually we're pointing at the character 8. And then this will be false. So the current character it's pointing to is 8. And because we did this, we're modifying that pointer variable as well. So we can just use it directly and it's pointing to the 8. Yeah. Other ways to write that, if that's slightly confusing or if you like array notation, another way to write this is I could just start with int I equals 0, and then in my loop, I could iterate while the character I'm pointing at index I is equal to 0. And then instead of doing pointer arithmetic, maybe I just want to do this. So I'm just finding the index of the first character that is not equal to 0. And then for my put s, all I have to do is one instance of pointer arithmetic, right? So that will give me the integer that is telling me the index of the first non-zero character. So if I were to print it, I could just do stir, which is the string. I do not modify it. I do never modify that pointer. So I could just do stir plus I. And again, if I compile and run that, it gives me the correct answer as well. Two different ways to write it. Depends if you want to use the array notation or not. Keep track of a variable called I, or do some pointer arithmetic, which is fun. All right, any questions about that one? Yeah?
If there's a 0 at the end or like in the middle after the initial ones go, wouldn't you get rid of that?
Oh, so the question is, if there's a 0 at the end, wouldn't this get rid of it? So the answer to that is no, because it would stop at the first non-zero character, which is remove leading zeros. And we can try that out, so we could put some zeros here. Oh, it's not big enough. Good thing my compiler's smart and warned me. So if I run it now, it won't remove any of the other zeros. Oh, it wasn't big enough. Sorry. So it won't touch any of the other zeros because it stops as soon as it reaches the first non-zero, and it wouldn't touch any of the other ones, right? If the question was remove all the zeros in the string, then I would have to, I can't modify it in place, probably. Depends on what you're allowed to do, if you're allowed to use the memory for the string that they provide you, or if you have to malloc your own memory for it. Yep.
I remember seeing that at the end of the string there's like a null byte, and that's when C knows when to stop reading.
Yep.
So what's the difference between like a null byte or a 0 and like 0 actually in the...
Oh yeah, so the question is, so C strings are null terminated. So null terminated is just the value 0. Does that mean that, hey, this is just the value 0, so it should just terminate as soon as it sees a 0? So the answer to that is no. So in order to write the null byte, to write it, we have to do \0. So that is the null character, which is the value 0. This is the character 0, which is ASCII encoded. So I forget the value off the top of my head. Let's see. The value of a plain old 0, I think, is like 30 something. So if you go to ASCIItable.com, the value of 0 is oh wait, that's the wrong one. Is 48. So the value of the character 0 is 48 if we were to use it as like a whole number or a decimal number. All right, any other questions with this fun one? All right, let's do something harder then. So this one is a mouthful. So it says, write a function called last string in string. The prototype is provided below. That returns a pointer to the last occurrence of string S1 in the string S2. If the string S1 cannot be found in the string S2, the function returns null. So immediately reading this, that sounds a lot like stir that we saw yesterday, except stir returns you the first instance. You might think a solution is just like, okay, well, let's just keep doing stir, saving the values until we find the last one and just return the last one. But if you skip to the bottom, it says, note, you can use any function in the library string.h except for stir. You are not allowed to use it. So with that, it gives some examples. So for example, if we were looking for the string is as S1 in the string, this is a sample string as S2. The pointer to the second is in the string S2 will be returned by the function. So that's because there is two instances of is in the string. So there's an is as part of this, and then there's an is as just the word by itself. So it should return a pointer to the start of the second is, not the first one, as stir would probably do. And then another example is if we're looking for the string the with a lowercase t as s1 in the string s2, capital T, the apple, the function should return null because t is lowercase in the. So we are doing it case sensitive. So give you a minute to think about that. Think about how you would solve this, because there are, I mean, like with all programming things, there are several ways to solve this. The solution provided, if you look at it, is very, 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 very wordy, and we can do better. So have a think about what you would do. Try and think like just how you would solve this if you were just given a piece of paper, because as we all know, computers are just really dumb and you have to tell them exactly every step to do. So I'll give you a minute to think about that. Alrighty, we have some good solutions. Or any ideas what we should do to do this? Yeah?
We could start with the edge case where the second string is bigger than the first string.
So start with the edge case where the second string is bigger than the first string. So we could do that. So let's go here. So if I'm thinking about edge cases and with respect to the length of the string, well, if I want to determine the length of two strings, I don't have to write my own function for it. I could use stir length, right? So let's go ahead and start that. So let's create an int called stir s1 len is equal to stir len s1. And then we could also do, I should look at the correct monitor. So we could do s2 len is equal to stir len s2. So now we can think of our edge case where the string s1, so if s1 is greater than s2, so s2 is the string we are searching for, then there's no possible way it could be in that string. If the string we're searching for is bigger than the string that we're searching for it in, can't ever possibly be one. So we could just go ahead and return null. All right, so if we carry on now, we know that s1 len is less than or greater to s2 len. So what should we do now? Any ideas? Any help? Yeah.
I'm honestly not sure, but maybe use a string compare.
Yeah, string compare, that's probably good. So if we look at the example, so S1 is something like is. This one is, this is sample string. So why don't you use something like probably compare, because I want to see if their values are the same, right? I can't really do something like, if I just do string comp S1, S2, and then remember, it will return 0 if they're exactly equal. I probably don't want to do something like that, right? So if that, so that will only be true if the entire strings are equal, right? Because they have to be null terminated. So probably want to use strcomp. How else should I think about it, or how do I have to adjust the pointers, or what do I have to do in this case? Yeah.
Okay, it's probably very inefficient, but get the size of like like the inner string, and then like if you see like 3 times, let's say the size is like 3, right?
Yeah.
3 zeros.
So let's go with this example. So right now, S1 is equal to is, so its length is 2.
Okay. And maybe if you get like 2 zeros, you know it's the same.
2 zeros.
Yeah, because like if S1 equals S2, like if the if statement is true twice.
So if the if statement is true, if this is true, that means the 2 C strings are equal. Will this ever be true? It will only be true if their contents are exactly the same, right? So any other ideas what we should do? That's getting close. We probably want to use strcomp in some place, and we probably only want to compare 2 characters at a time. Any solutions at all? Doesn't matter how inefficient. Yeah?
Should we use stern compare for the n, and then we can do it for the length of?
Yeah, so that's a good one. So we probably have to use str_n compare, because we only want to compare up to the number of characters in S1, right? So that would be S1 lang. And then that way, what we're looking at in S2, the big string doesn't have to be null terminated, right? Because we don't want to check to the end every single time, because even on the first one, if we went through and changed the pointer, so if we started with S1 equal to a string or a pointer pointing to the capital T, that's not going to match. The H isn't going to match. And also, if we're pointing to this I, that should match. That should be the first match of is, right? But if we do strcomp without the n, it will compare all of it to the null byte here. So it will compare the string is to is space is a sample string, so they will never be equal to each other in this case. So that's why I probably need to use something like strcomp. And then, like I did at the beginning, I just went through all of them and kept track of like, hey, does this match? Hey, does this match? Hey, does this match? Hey, does this match? So I could do something like create a variable called a char star. So it's a pointer. It's a C string. It's just a pointer to a char. I could call it match and initialize it equal to null. And then in a loop, I could look at the first character and try and find something that actually matches, right? So I could have something like, if I'm iterating over every single character in an array or in a C string, I could do something like for int I equals 0. If I want to do any array subscripting or anything like that, I can just do it based off index. And then I is less than, well, I don't even have to, go into the null byte. I know the length of the second string, right? So I could go less than S2 len, I already did it, plus plus I. And then in here, I can check, whoops. So in here, I can check if my strings match up. And what I want to do is, S2 is the beginning of the large string. So if I don't want to modify it, I want to look at it with a different starting character, I can just do my pointer arithmetic here, right? I can just do S1 plus I. So the first time through, it'll be 0. That's starting at the first character, then the next character, so on and so forth. And then if it's str_n comp is equal to 0, with that limit, it means that they are exact matches up to 2 characters, which is what I'm looking for. So I can update match, because match is currently equal to S2 plus I. So if I wanted to, I can see here I repeated S2 plus I, so I could just rename it if I want. I could just call it, char something that's not creative, or yeah, I could just call it S, and S is equal to S2 plus I, so that's the current substring I'm looking at. So I can just update it here just so that, hey, I don't have to have S2 plus I places. So this will update it. It goes through starting at the beginning to the end, so every time we find a match, it will overwrite it, so we'll be pointing to the most recent match. So if this was our input, right, we'd start off looking at T. TH does not match is, so that would be false, and we start looking at the H. That does not match. Then we start looking at this one. I is, or IS matches IS, so match would be updated to point to this I. But we keep on going, right? We don't end early. Then this doesn't match, this doesn't match, this matches. Match will be updated to point to this I, and then that's the last time it matches throughout the string. And in this case, we would actually compare this character G, but it shouldn't matter because we actually have a limit anyways. You could micro-optimize it a little bit that, hey, stop here because I need to compare at least 2 characters, but remember, there's a null byte at the end there, so the stir comp will just end early, so we don't have to worry about it. So could do something like this. So if we do that and run it with the example input, we get exactly what we expect. So it returns us a pointer to the second instance found, so it would be a pointer to this I. So if we print it as a C string, it will just print off the rest of the string. So we get what we expect where it says is a sample string. So any questions about that? Yeah? Go up a little bit.
Sorry, could you explain that statement, the string comp, with the S1 and S?
Yeah, so this.
S2 plus I.
So S is S2 plus I because S2 plus I is going to be pointing, like in that whole loop, we're just changing the character in S2 we are starting from, right? So we could do it, you could do pointer arithmetic, you could do whatever you wanted. In this case, I'm doing just pointer arithmetic using an index because I know the length already. So here, I'm changing it so that inside the loop, S is equal to like the starting, where I'm starting my search from in the big string. So first time through, I'm starting it at this T at the beginning. So that's what S would be equal to. Second time through, when I is equal to 1, S would be pointing to the H. When I is equal to 2, it'd be pointing to the I, so on and so forth. So we're just doing pointer arithmetic because, well, that's all a C string is. It's a pointer to a null terminated string. So we're just changing where we're starting from. Yep. All right, any other questions with this fun? Yep.
If you wanted to print only the is, like at the very end, how would you do that? Like if you only want to print a certain section of a string.
Yeah, so the question is, if I only wanted to print a certain section of a string, how do I do that? Like if I only wanted to print the is in a big string. So you do not technically know how to do that. I can show you how. It won't come up because it's not super testable, but just in case you're curious, because, right, result is going to be this. So let's say we're just printing S, right? S expects a C string, so it'll just blindly keep on copying bytes until the null byte. You can't tell it how many to actually do. If I do want to tell it how many to do, there is a special string format specifier. So let's do substring. So like with the stir n number functions that you say how many characters you want to go up to, we can kind of abuse the, not abuse, but use the string format specifier. And one thing we have not shown you how to do, but that you can do, remember we had this to like take, the first whatever characters. Let's do 2 characters. Oops. So this doesn't need it to be a terminated string, right? It would print the first 2 characters. So that answers part 1 of the question, but you might want to be like, okay, well, I want to print some number that I don't know until I actually run my program, right? So what you can do to make it print the number of characters using a variable is instead of this 2, I can replace it with a star. And when I replace it with a star, I'm telling the printf that I want to tell you how many numbers to truncate it to, which is the number of characters to print, and I'm going to provide it as an argument. So I can do something like this. So if I do star s, then it uses a 2 to replace this. So this is how many characters to print, and then this is the string to start using. And then that way it doesn't have to be null terminated. So let's change this number to 4, because we should get the string this space a. So if we run it, we can see, yeah, we do get this space a. But it might be useful when you actually write programs, but we won't be tested on or anything like that, because that's kind of a weird format specifier. All right, any other questions? Yeah? Can you do the same star for other format specifiers? Probably. LF. So let's say it's a number. 1, 2, 3, 4, 5, 6. So if we do something like that, it seems to compile, seems to not complain. So let's see if we can do that more generally. And it says, yeah, you can. So you can specify the number of digits to round it to at runtime if you don't know it ahead of time. So yeah, you can do that if you want. All right, any other questions? All right, so let's do something more fun then, that we can write a useful program. So again, not testable, but useful, and it will help us understand strings and the way people actually normally write programs. So there's actually another function prototype for main. So main actually does take an input, and now we can finally explain what it is. So like before, main always has to return an int, but there's a version of main that takes an array of C strings. So its function arguments are int argc, so that's short for arg count, or how many strings main is accepting as input. And then there is this fun thing. So this, looking at the type, we can actually read it now, right? It is an array of pointers to chars, and the pointers to chars are C strings, so they are null terminated. So this version of main allows you to access the arguments used when you type to run your program. Like if you've run the compiler by hand, you did like clang space and then your file name and things like that. So if you wanted to use the things you type in your terminal after the program name in your program, use this version of main. So, and then argv is the array of C strings you type when you ran your program, and it is short for argument values. So that's argc and argv. So your operating system will go ahead and remove white space for you. So let's assume we have a program named des to hex. So decimal number to hex number. So if I run it with like dex to hex 255, then by convention, this is how it works. argc will be equal to 2. The first argument will be the name the user typed to run your program, or the name of your program. So in this case, at index 0, it would be dex to hex. And then the second argument would be the string 255. So even though that is a number, it's always strings that are inputted to your program. So let's just write that program. That should be fun, right? So we'll convert a decimal number to a hexadecimal number. So if there's any problems with the input, what we're going to do is exit with exit failure. So a to I, that's not a great function because it's hard to handle errors from it. So if there's an error, it just returns 0. But if we want 0 to also be invalid input and to exit if the user inputs something valid instead of continuing with the value 0, we have to write our own function for this. So they don't do it because a function that is a library function, when you call it, if it exits your program, that's generally bad. So we can write our own version of this program. So I have set aside out some help or some structure to this program. So in main, we're going to use the new main prototype in order to write main. So it has argc and then argv, which is again an array of C strings or an array of pointers to chars, and those pointers are pointers to chars, which eventually ends with a null terminated one. So here we'll check that the number of things the user typed is exactly 2. So if it's not equal to 2, we'll just use that exit with exit failure. If this was a real program, we'd say, hey, you need to type a number or whatever like that. But we're just going to immediately exit and just have our program end immediately if something bad is going on. So the first function we're going to write is called string to int. So we should be actually able to write this now. I can help you a bit with the weird ASCII tricks we can do. But here it gets argv at index 1, which is the second thing the user typed. And then here I have output. So I've already structured this, so that's kind of reusable. So this takes an integer and then returns a hex string for you. So in here, we're going to need to malloc because the string didn't exist beforehand. So I just have a placeholder that mallocs a single byte. And in order to make it a valid C string, I just make the only value equal to the null byte. So that's one way to represent an empty string. Then I print out whatever the output is, and then I free it because I malloced it so that Valgrinn's all happy, and I don't leak memory or anything like that. So we've broken off this problem into 2 things. So the first one would be given a string, so something like, I don't know, so something like 1, 2, 3 as the string. I want to convert that to the integer 1, 2, 3. So any ideas how I would do that? And I'll give you a hint. So here, or I'll write out the kind of tricky part. So the kind of tricky part is just getting a single digit, right? Because if I access the characters of the string, I probably want from the character 1 to get the integer 1, right? And to do that, I can use a little bit of a trick. I can take, if I have a digit, so if I have if I have a variable called digit, what I can do is just if I have char digit, so if it is a character that represents a digit, then I can just go ahead and subtract the character the character 0 from it, and that will give me the value, the integer 1. So it's kind of knowing that ASCII's laid out character by character, they're all sequential. So in this case, if I did something like, if car digit was 0, it would be the character 0 minus the character 0, and that would convert it to their ASCII or their ASCII equivalent, which is 48 or something like that for this. But it's just whatever that number is minus whatever that number is, so that would be equal to 0. And then similarly, if I did 1 minus the character 0, that would be equal to the character 1 because it's 1 away from it. So in general, I can just do car digit minus 0 to get a single digit. So knowing that, we've kind of, the rest of it is like I kind of want to just iterate over every single digit in the string, right? So how would I do that? Yeah.
Use the for loop to iterate stir len of s times.
Yeah, I could do a for loop. I could go for I equals I is less than Stirling string if I wanted to. That's definitely something we could do. Plus plus I. And then I forgot to write an int. So this is giving me an error. Oh, because I didn't include string.h. So include string.h. So I can do that, and then it's also going to complain that my variables have different sizes. So stir length returns an unsigned, which is a positive value, but it's comparing it to something that can go negative. So to quiet C up, I can just cast it to an integer, and then everything is fine. So that would iterate every single character, right? So if I do something like SI now, that's a character. So it would start at the character 1, then 2, then 3, and so on, right? So what should I do now? I could do that digit minus 0, right? So that would give me a digit now, right? All right, what do I want to do with that digit? Yeah?
You add it to the value.
Yeah, I can add it to the value, right? So I could add it to the value, so value plus equals that. All right, anything else I need to do? Yeah?
Before that, you have to multiply value by 10.
Yeah, yeah, so that's exactly the trick. So here, if I just did this, right now it would get the character 1, add 1 to value, so value would be 1. Then look at this character, value would be 3 after I add the 2, then value would be 6. Don't quite want that, but we can take advantage of the thing the fact that this is a decimal number, so every number is essentially an addition to the tens column. So every time I look at a new number, I can multiply that value by 10, and that will shift the previous digits all over by 1. So I could do value times equals 10. So now, first time through, value is equal to 0. 0 times 0 is 0. So that doesn't do anything. Then the first time through, s at I minus 0 is equal to 1. So it would just add 1 to the value. Then the next time through, we're going to be looking at the character 2. So it multiplies that value by 10. So now it shifts it over by 1 bit. So now we get 10. 1 times 10 is 10. So shifted it over, that whole number over a column, then we add 2 to it, then we'd get the number 12. Then we'd look at the last character, it would shift it over another column, so we'd get the number 120. Then we go ahead, add the character or the value 3 to it, we get 128. So that is one way we can do it. If we want to go ahead and make sure things are safe, we can also make sure that the character we're looking at is a digit, right? So I can add a little if statement here that says if the character I'm looking at is less than 0, or the character I'm looking at is greater than 9, which is the last digit, then that's an invalid input, and I can just like exit failure. Oops. So that way I'm also determining, well, that way I'm also throwing out invalid input. So if the user, let's go ahead and type this, we can compile it, unused parameter value. Oops. Oh yeah, we don't use in the other function, so that's fine. So we can see if we actually successfully converted it, so we could just do input D, just write our own printf just to verify that we did it correctly. So we can compile. Then how we run it is it would be build dex to hex, and let's just do 1, 2, 3. And we can see that indeed we did do the correct thing, so we converted it successfully to an integer. So that's basically what A2I does. So now A2I does that, but in a worse way because it doesn't really error check. So we've done the first part. What about the second part? So now we have an integer value, in this case, it'd be the value 1, 2, 3, and we want to represent it as a hex number, or as a hex string. Yeah?
Does ABCD come after the numbers in ASCII?
In ASCII, yeah, ABCD comes after the numbers. But we want to output the hex string, so we're outputting like ABCD. But I kind of see what you're getting at. But yeah, yeah, it comes after, but shouldn't matter. All right, well, what about if my input, let's start it easy. What about if my input was something like 15? How would I convert that to hex? Uh-oh. Or if it was a number, okay, we can back up. If that was a number in decimal, how do I iterate over every single digit in it? We've done that before, right? Yeah, mod 10, right? We just mod 10, keep on going through it. So if it's a base 16 number, we do the same thing and we mod 16. So in this case, if we were going over it, we can develop it slowly over time. So we get that value. We could start off like, if we wanted to iterate over everything, we could create a variable called remaining equal to value, and then I could have like a while remaining is greater than 0, right? Whoops. So while remaining is greater than 0, what I can do is I can, if I wanted to get the one hex value, I could mod it by 16. That gives me the actual value, and then I can do remaining divided by, or divide equals 16 to make it a bit smaller every single time, right? So if we were to do this, we could do something like printf. Let's just print off whatever that value is. So we can just make sure we're being sane. So if we do that and we get the number, let's say we get the number 255, which I know is FF in hex. If we run through it, we get the number 1515 each time, and 15 should be converted to an F, right? So first thing is first, if we want to malloc, we need to know how much space to actually have for the output string. So we only know that by knowing how many hex digits there are, right? So I could create a variable called int hex len is equal to 0. And then here, each time through the loop, I can go ahead and do ++ hex len. Right, so if I do that, I compile it, I run it, whoops, and I output now the length of the hex number. I can see that it is 2. That's good. That tells me how many characters I need to malloc, right? So the number of characters I need to malloc, I already have a placeholder here, is we need to malloc hex len +1, right? Because we need to hold all of the characters for that hex string plus the null byte at the end, right? So another way to think about this too, when we went through it, we were going from the least significant hex digit to the most significant hex digit, right? So if the number was, I don't know, what's a good number? So if the number was 32 or something like that, we would get, well, we would first get 2, then 0 in the 16th column. So the first number we'd get for remaining would just be 0 as the hex digit here. So, So we're essentially going to fill it from the back. So we're going backwards, forwards. So if I create a variable called int I, which is keeping track of the index at the last character, and we move to the left, I can start it with I equals to hex len. So that is the index of the last character. And then I can make sure that it's null terminated like that. So make the last character a null terminated bit. And then after that, I can do the exact same while loop I had before. So I can just copy this. Now I don't need to copy that hex length anymore. So reset remaining back to the initial value that I got in this function. And then through this while loop, this remaining, if I did remaining mod 16, that's the current hex digit, right? So what I could do is I could do something like int, let's call it hexit. So this is the value of the hex digit. So it will be something between 0 and 15, right? So if the hexit is less than 10, it means I should output a normal digit, right? Between 0 to 9. So how I could do that is I can do that same ASCII trick I had before. So I can make SI equals to hexit plus, in this case, plus the character 0. So that will go ahead and just add the current value of the hexit, which is a number between 0 and 9, to the character 0, and that would give me the characters 0 through 9. And then otherwise, I know the hexit is 10 or greater, and what I can do, the little trick I can do here is assign it equals to hexit, and then the lowest value is 10 at this point, right? So if I want to make sure that the lowest value is equal to 0, I could do minus 10, so the lowest value is now equal to 0, and then I could just do plus capital A. So that will give me A through F for the rest of them. And then the only other thing I need to do here is minus minus I, because I'm going backwards, and I also need a minus minus I here as well. So everyone okay with that? I'm filling in the numbers from the back and going forward. All right, so I return S, whoops. So now if I compile and I run my program, hopefully it works. Whoops, address boundary error. All right, we have already screwed up. So what did we screw up? We can go ahead and use Valgrind. What did I do? Oh, whoops. I did not change remaining minus equals. I didn't adjust remaining every time, so just infinite looped itself until it until it accessed invalid memory and it died. So now if I do that, hey, it seems to work now. So 32 in decimal, if I convert to hex, is 20. So this, if this was hex, this is the ones column, so 0 in the ones column, and this would be the 16s column. So for 32, there's 2 16s, so it would be the hex number 20. And I can do other fun numbers. So 255 is FF, 256 is 1000, so on and so forth. Lots of fun, huh? So only other thing is there is a slight edge case here that you may not see, and that is if the current value, if the value given to this function is just a 0, things will not work. So we do have to think about our edge cases. So if I do 0, it just prints out nothing. Because, well, in that case, thankfully, given how I programmed it, it didn't crash or anything like that. But if the value I give it is 0, then remaining will be 0, and then this will just exit, and the length of the hex will just be 0. So I only allocate 1 byte, and it is just empty. So in order to fix that, I could just special case that if the input is 0, just make hex length is equal to 1, and just write the 0 character to the first one and be done with it. But there is a slight edge case here for the value 0, so that is also something you have to be wary of. But we've written our first useful program, so now you don't have to do user input anytime. You could do this, and then it's easy to convert from hex to decimal anymore. So now we can take the value 48, see what it is. Oh, hey, it's 30. I don't know. Lots of fun. I don't know. I'm easily entertained. But with that, we are out of time. So just remember, pulling for you, we're on this together. And next week is recursion week. So that will probably be the hardest topic. So please come with your thinking caps on. All right. Good luck.